Great. So my name is Jordan Swain Fox. I'm the outreach coordinator for the Center for Urban and Regional Analysis, or CURA, at The Ohio State University. And we're excited to welcome you today to the second webinar in the series Public Data for the Public Good. We're co-sponsoring this series with the Research Commons at the University Libraries of Ohio State. And throughout the series, we're hearing from speakers who will discuss the importance and impacts of public data access, use, and preservation. Today, Karen Majewicz will discuss the issue of ephemeral geodata and what organizations can do to ensure that contemporary geospatial data are preserved for future users. Before we introduce Karen, I just want to mention a few logistical items quickly. If you require closed captioning today, you'll find a box at the bottom of the screen labeled CC. Click this box and select Show Subtitles, and that'll allow you to view subtitles during the presentation. And then throughout the webinar, you can submit questions using the Q&A box, and we'll ask as many of your questions as we can in the last portion of the presentation. You'll notice that chat has been disabled in the webinar today, so you can also use that Q&A function if you have any information to share with the event organizers. As you may have seen on our website, this event is approved for 1 AICP CM credit. To claim your CM credits, log into your My APA account on the APA website and enter the event into your online CM event log after the end of the presentation. There'll be a brief survey at the end of the webinar today, and we'd love for you to provide your feedback to help us improve these events. If you have any additional questions about the survey, the webinar, AICP credit, or anything else, you can contact me at swaim-fox.1@osu.edu. Finally, to learn more about CURA's future events or to sign up for a monthly newsletter, you can visit cura.osu.edu. You can also like us on Facebook and follow us on X and Instagram. To learn more about the Research Commons, you can visit their website, library.osu.edu/researchcommons. And with that, I'll pass it over to Josh Savari, who's the Research Commons Geospatial librarian, to introduce our speaker for today.
Hi, everyone, and thanks, Jordan. I'm very excited to introduce my colleague and collaborator from the Big Ten Academic Alliance Geospatial Information Network, and I'm looking forward to today's important discussion. Karen Majewicz is the Associate Director of the Big Ten Academic Alliance Geospatial Information Network at the University of Minnesota, where she leads technology and data curation activities for the BTAA GeoPortal. Her research interests include metadata standards, open data, digital archives, and the history of national spatial data infrastructures. She holds a Master's of Geographic Information Science from the University of Minnesota. Karen, I'll turn it over to you to talk about sustaining future historians, the case for preserving ephemeral geospatial data.
Hello, everyone, and thank you for joining me today. So my talk today, it focuses on a deceptively simple question. What happens to public geospatial data over time? We are living in an era of rapid data creation. Millions of data sets are published on open data portals each year, but how many of them are being preserved? And what will future researchers find when they go looking for the digital equivalent of historical print maps? We'll begin today by looking at current government data practices in the United States, including how many foundational geospatial data sets are published, revised, and retired, followed by a look at collection practices in map libraries and how the shift to digital formats has disrupted long-standing stewardship models. I'll then share examples from my work managing a multi-institutional geospatial metadata portal and describe the risks of what I'm calling an impending digital dark age. Next, I'll provide an analysis of the actual temporal coverage of maps and geodata held by libraries and public platforms. And then through 2 collection studies, I'll show how the shift from print to digital has created a growing gap in what we can access over time. From there, I'll broaden our lens to compare how a few other countries manage geospatial data, and drawing on international examples of national spatial data infrastructures, I'll share my preliminary research on whether different governance models support better long-term stewardship. Finally, we'll return to the role of libraries. I'll outline some barriers, highlight success stories, and offer strategies for institutions who want to preserve public geospatial data for future use. Before we dive in too deep, I want to clarify the scope of what I mean by public geospatial data, or sometimes I'll just say geodata. These are foundational spatial data sets created by government agencies, things like tax parcels, street networks, zoning boundaries, address points, things that support geographic analysis, public services, and academic research. So in the United States, the bulk of these data sets are created at the local level, cities, counties, and municipalities, and may later be aggregated into larger state or national frameworks. For example, county parcel data might be compiled into a statewide cadastral map or incorporated into a national emergency response layer. And this multi-tiered structure with local creation, state aggregation, federal coordination, it means that the responsibility for preserving public geospatial data varies, and the accountability for who's supposed to be doing that is unclear. And that's part of what makes this issue really challenging and important for us to address. All right, so part one, the problem of ephemeral data. So I'd like you to imagine the year is 2075, so 50 years in the future. And our scenario is that a researcher contacts a library seeking geospatial information to document how a city transformed from its industrial decline in the 1980s to an urban revival in the 2020s. To do this, they need historical high-resolution geospatial data, zoning boundaries, land parcels, streets, and building footprints. So the question arises, will data from today still be accessible? If our current practices continue, the answer may be disappointing. A librarian would likely be able to provide 20th century print maps, but have little to offer for the 21st century. This is because few organizations are systematically archiving public geospatial data, particularly at the local level. So as a result, we may be living through a time that future scholars will regard as a digital dark age. This looming threat is not born from a lack of information, but rather from our collective failure to save and archive ephemeral data. So data ephemerality, by that I mean resources that are available one day, but disappear the next. And many foundational data layers are in a constant state of change. The life cycle of public geodata in current practice is characterized by revisions, and regular revisions overwrite yesterday's records. So let me step back for a moment and explain what I'm talking about in the context of my role as manager of the BTAA GeoPortal. So this is a multi-institutional metadata catalog that points to open government data, as well as library-held scanned maps and geodata and other useful geospatial resources. The GeoPortal has been active since 2016, and during that time, I've witnessed firsthand how public geospatial data is ephemeral. So here's an example of that. In 2019, I saved an inventory of data sets from 30 different government open data portals across the Midwest of the US. And then in 2023, I repeated this inventory for the same portals and I compared the results. So for this comparison, I focused on data sets representing 3 years, 2017, 18, and 19. So this is a bar chart of the 2019 inventory. You can see that I found almost 3,000 data sets with a temporal coverage for that year, 2019, and a sizable number for the previous 2 years. By 2023, many of those earlier data sets had disappeared, and this left me with some questions, like had the retired versions been retained or were they simply overwritten? Some data sets, if they were just updated, what might have changed, what might have been lost? And were the older versions archived anywhere? So when we've talked to data providers about this, one of the questions that they come back to us is to say, why is this even a problem? Last year's version is outdated, so why would anybody even want it? But the answer is that researchers, especially in academia, rely on temporally specific resources to conduct longitudinal studies that analyze changes over time. Furthermore, complicating this is that if data providers are actually storing historical versions, but quietly in a dark archive, such as in a hard drive in a drawer in their desk, which is where a number of them have told us they have them, researchers might assume that that data does not exist. And so now let's turn to collection practices in libraries, in map libraries. So in the past, libraries collected and preserved public geospatial information in the form of print maps. And as a result, today's researchers can explore library catalogs containing hundreds of thousands of maps spanning the globe and representing centuries of cartographic history. These collections remain a vital resource for all kinds of historical research. The federal government has been one of the largest sources of geographic information through programs like the Federal Depository Library Program. Designated libraries have received print maps and even some digital data on physical media, such as CDs, for years. In recent years, however, federal agencies have shifted entirely to digital distribution. They're no longer sending physical maps or even CD-ROMs to libraries. So instead, what libraries do is to create a catalog record in their library catalog pointing to various government websites where users access the data directly. So generally, most libraries are no longer hosting or preserving local copies of this kind of federal government data. And users are no longer going to libraries to access them. They're just getting them directly from their local desktop. Local governments also have produced and distributed maps covering topics like state parks, highway maps, and city infrastructure. These were also major sources of publicly accessible geographic information collected by libraries. In addition, there used to be a lot of third-party companies that created commercial paper maps based on public local data. But today, most of those companies have either ceased production or gone out of business altogether, removing yet another source of print geographic information from libraries. So today, the way to obtain local geospatial information is to first hope that the region in question has an open data policy, and second, that it hosts a data portal. However, if you are looking for older versions of data, you will probably be out of luck. So these portals typically only provide the most recent version of each data set with little to no access to historical versions. So for those seeking older data, this presents a significant barrier as past iterations are lost or possibly overwritten. So this shift from collecting durable physical materials to relying on fragile digital access points has disrupted our ability to track changes over time. So as libraries move from stewardship to signposting, that is from directly preserving materials to merely pointing users to external sources, the continuity of the historical geospatial record is quietly breaking down. So to understand the extent of this disruption, a few colleagues of mine and I analyzed the temporal distribution of geospatial resources available through libraries and public data portals. So we found a gap between the end of the print map era and the rise of digital data. So while we all may be intuitively aware of this growing gap in digital information, a collection analysis makes it more visible. So to illustrate it, we conducted 2 studies using library-held maps and public geodata and treating them as part of a single unified timeline sequence. We used 2 tools for metadata aggregation. So for library maps, use the BTAA collection analysis tool. So this is a pretty cool tool that if you are a member of any BTAA organization, you can actually access this. And it covers all the BTAA libraries, and it compiles over 100 million MARC records and allows you to compare holdings, create reports, and generalize visualizations of their library collections. And for geodata, we use the BTAA GeoPortal. It has links to current resources from hundreds of state, county, and municipal data providers across the Big Ten region. So in our first study, we assessed the availability of resources to support a hypothetical researcher investigating the evolution of roadway infrastructure in the city of Minneapolis. So we surveyed the University of Minnesota's Borchardt Map Library to find road maps published since 1950. And for data, we searched the state, county, and city open data portals. We ultimately identified 73 maps from that library and 12 data sets from 3 portals. And then we categorized each resource by year. So here's the distribution of the print maps. Most of them are from the mid-century. There's only 2 in the collection since the year 2000. And here's the distribution of the data sets. They mostly represent the year 2023, which was the current year at the time of the study. So we combined both of these sets into what's called a presence-absence timeline to visually indicate whether any relevant resources are available, regardless of whether they're maps or data. So our hypothetical researcher could use maps to trace road evolution throughout the second half of the 20th century. But to continue on, there's some pretty big gaps. So they might have to unearth some hidden collections to go further there. Our second study was similar, road maps and geodata, but employed a wider scope. It covered a pretty large area, the 11 states in the Big Ten Academic Alliance as of 2023. I'll note that there are more institutions in the Big Ten today, but it was 11 states at the time. And we also expanded the time period to a 100-year period. This study set resulted in over 12,000 maps from 15 universities and 340 data sets from 71 data providers. So let's see, here is a visualization of the map holdings. So I like this chart because I feel like you can learn a little bit about cartographic history here. Road maps started growing in the 1920s and 30s with the automobile boom. It dropped off quite a bit during World War II, but then surged again post-war, peaking in the 1970s. Stayed high for a little while, but then declined sharply after 2000 as digital formats took over. And here is a map of the data sets. Although a handful of items exist from the 90s and 2000s, the majority are concentrated in recent years. So this chart exhibits a long tail kind of effect, sloping downward into the past. So graphing these together reveals a low period between the waning print map era and the present day. So this kind of era right here. But if you recall my example of data set persistence in the government open data portals, it makes sense that many of the data sets from 2023 have actually already been overwritten. So what we can predict is that this shape will continue to form, and that the long tail will continue to attenuate as the gap continues to widen. So seeing this persistent gap made me question why governments aren't systematically preserving their geospatial data. And this brings us to part 4, exploring international approaches. So, to better understand what's going on, I decided to look a little more broadly at how other countries manage their data to explore different governance models, see how they influence data discoverability, openness, and long term preservation. I wondered, could international practices offer some different or even better solutions here? So I approached this research by exploring the concept of national spatial data infrastructures, also abbreviated as NSDIs. These coordinate governance, technology, and data sharing practices and policies at the national level. So this concept of an NSDI dates back to the early 1990s, and it's now present in most countries. So as I looked into it, I discovered that NSDIs are a vast, almost overwhelming topic to look into. They're full of sort of dense legislation, evolving policies that often replace each other as administrations change. And there are a lot of different comparative models for ways that you can compare one nation's NSDI with the other. So to keep the scope more manageable, I adopted what's an experiential approach. So I chose to search for one foundational data layer common to most NSDIs, that of national address points. So this is a high value data layer common to most NSDIs. It's used for geocoding. If you've ever done any geocoding, it's often using this kind of a data set for navigation, of course, and for emergency response. It excludes personally identifying information. So it's not like parcel data, it's a little bit more anonymous than that. And what I did was I scoped it to just data sets that were national in coverage and maintained or created by federal agencies. So what I did was I went to the official national open data portal for a bunch of different countries to see whether I could find this layer, whether I was actually able to access it, and if any historical versions were available. So although I initially explored a bunch of portals, I eventually focused and narrowed my scope to just 6 countries. And this was influenced by a few things. For one, I was kind of more familiar with these countries, but also I read an article by an author, Sukema, and his colleagues that identified 3 models of NSDI governance. I realized that I could group a few neighboring pairs of countries that had what we would call like mature NSDIs that have been around for a few decades into each model. So the first kind of model is voluntary or laissez-faire governance. And this is where participation in the NSDI is not mandated. And so we see this model in the US and Canada. The second is more hierarchical, where there are strong central mandates. In Europe, this has been influenced by something called the INSPIRE Directive. And the INSPIRE Directive requires all European Union members to create foundational GIS data sets using predefined standards. And so for the hierarchical model, I looked at the UK and Ireland. So even though the UK has left the European Union, they're still trying to follow the INSPIRE model, and overall, the country still displays aspects of strong centralized coordination. And lastly is a model called cooperative or network governance. And so this is more where partnerships and collaboration are at the forefront. Australia and New Zealand, which collaborate on quite a few geospatial initiatives, seem to best represent this model. So here's a chart showing what I found when I searched for national address points in each of these 6 countries. So I was indeed able to locate a data set for each country. However, in the UK and in Ireland, the data sets are not freely available to the general public and must be purchased. As far as completeness, the US data set was the only one that was incomplete, reflecting the voluntary nature of its system. Fewer than half of US states will share address point data with the federal government. And because federal data must by law be open and free, any state, county, or city that doesn't want its address points made public can simply withhold them. So I should say that the US Postal Service and the Census Bureau actually do maintain versions of a national address data set, but legally they are not allowed to share or distribute them. So finally, regarding historical versions, I was pleasantly surprised to find that there were a few national portals that offered them. So Australia provided downloadable snapshots of address point data every few months, going all the way back to 2016. And New Zealand Geospatial Data Portal, it doesn't do that, but it offers something called a change set API, which theoretically could be used to reverse engineer historical data. So basically, it's an API that just saves the changes. I don't think they put this together to be a formal archival tool. It's just a very cool feature that, as I said, is saving the changes in sort of a versioned fashion. So based on this pretty simple search, I would say Australia and New Zealand kind of have come out ahead. Their cooperative model strikes kind of a productive balance. They're not overly centralized with mandates, but they're not fully hands-off and have sustained partnerships. So interestingly, the governance model, this corresponds to what the authors Sukema et al. Described as probably the most effective NSDI. So while I was doing this, I also branched out a little bit to see if there are any academic institutions preserving public geospatial data at the national level. I found a few things. There's something called Scholars Geoportal in Canada, which some of you may be familiar with. There's also a project called Adina Digimap in the UK. And I did find a couple of US state-based portals, although they were more scoped to the state. I want to emphasize that this part of my research, the NSDIs, it's pretty preliminary. I just focused on a few English-speaking countries, but it was interesting, and it did. I did come away with some observations that are shaping my thinking going forward. So we'll start with this. NSDIs are focused on delivering current authoritative data. The priority is operational use, not long-term preservation. So older data sets are often seen as redundant or even as liabilities. And while some government archives recognize the value of preserving geospatial data, there's little evidence that this is happening in a systematic way. So for example, the US Federal Geographic Data Committee published a report over 20 years ago recommending that all federal agencies work with the National Archives to preserve geospatial records. But it's unclear how widely that advice was followed, and anecdotally, I've heard that it really isn't happening. So just this year, 2025, another federal group, the National Geospatial Advisory Committee, called on the FGDC, the original group, to revisit their guidance. So in reality, federal digital record keeping in the US is pretty loosely enforced, at least for geospatial data, and it's mostly left to the discretion of individual agencies. So another point which kind of surprised me, I've gotten so used to open data in the US, is that there's a real disconnect between open data policies around the world and what's actually accessible. For example, if you look at international open data rankings published by various groups, the UK and Ireland both score very highly. However, the general public can't really access a lot of that data for free. You have to buy it, or a lot of it is sold through commercial vendors, even through these public-private partnerships. So on the other hand, because US federal data is open by default, states and local governments aren't really required to participate. And so national coverage ends up incomplete. So I sometimes think, like, what would I rather have, free incomplete data or costly sort of data that's interoperable and complete? Not sure. I'll also mention Canada. It follows a decentralized model similar to the US, with provincial governments independently managing data sets. But from what I've looked at, they've had a little more success than the US in building comprehensive national layers. So also throughout this research, I noticed a paradox. So archival efforts tend to be strongest where access is weakest, because libraries are most likely to collect geospatial data when access is restricted or threatened. So when data is freely available, institutions don't feel as much urgency to save local copies. But in places where access is restricted or unstable, libraries and universities have stepped in to make sure their researchers can obtain it. So for example, the Scholars Geoportal in Canada grew out of university licensing agreements that gave academic access to restricted government data. And the longest running example I found was Adina Digimap from the University of Edinburgh, which was launched in the mid-1990s to give UK universities access to Ordnance Survey data that wasn't otherwise freely available. And so following on this, when libraries do collect geospatial data, they don't just provide access the way the government does, they also preserve it. So unlike government agencies, they're more likely to save older versions instead of overwriting them. So in doing so, they become the stewards of the historical geospatial record. And so bringing up that Adina Digimap example again, they've become kind of an unofficial archive for the UK, managing historical versions of data sets that have since been replaced. They even keep offline archives that go all the way back to 1995, making it possible for UK researchers to do long-term longitudinal studies that would otherwise be difficult or even impossible. So building on these ideas, I would kind of think about our current environment and how the US maybe offers a cautionary example of how assumptions about data permanence can undermine preservation. So our current efforts around data rescue highlight how we cannot really trust that government hosted data sets will remain continuously available. And so in this way, I've been thinking about the idea that strong open data policies may have inadvertently discouraged preservation by creating an ultimately false sense of long-term stability. So part 5, taking action. What can libraries do? Our analysis of map and geodata collections revealed there's a growing gap in geospatial information, especially from the early 21st century. And this discontinuity poses real challenges for researchers trying to conduct longitudinal studies. So while a determined researcher might be able to track down older files from local governments or obscure repositories, doing so is time-consuming, inconsistent, and sometimes just impossible. So even more troubling is the pattern we've observed that today's data sets, sometimes they're just overwritten and replaced without retaining historical versions. So if this trend continues, the gap in accessible historical data will only widen. So new print maps are no longer being produced at scale, and digital data, although abundant, is ephemeral. So this graphic just kind of visually illustrates that trend. On the left, we have a wealth of 20th century print maps. On the right, there's a drop-off in accessible resources from the digital era. So here you see a projected future if we maintain the status quo. So the gap grows wider, access to historical geodata becomes increasingly rare. But there is a third path. In this scenario, libraries take deliberate action, preserving snapshots of at-risk data sets, curating digital collections, and building infrastructure to ensure that today's public data is available to future scholars. So this is how we could bridge the gap and prevent a digital dark age. However, as libraries confront the reality of geospatial digital data curation, it becomes clear that traditional collection methods do not easily translate to digital formats. So if a map librarian attempts to collect geospatial data sets the same way they once acquired paper maps, they'll likely encounter several obstacles. So for one, there may be no place to store the data. Most universities do feature some kind of an institutional digital repository, but we have found that they are typically restricted to research data, not public data. And the platforms may be designed for text documents, such as student theses, and don't fit data sets as well. So along these same lines, the data may not meet the requirements of an institutional repository submission policies. For example, tax parcel data sets generally contain owner names and addresses, which may violate the privacy policies of many institutional repositories. Furthermore, data providers may object to the collection. So although, excuse me, Although local governments may once have freely distributed their static maps, many now express considerable resistance to sharing their digital counterparts. This can be attributed to fears of liability, concerns about users accessing outdated versions, or the desire to maintain a financial model that charges users. And finally, the library may lack financial and staff resources to perform basic digital curation activities such as verification, description, or file format transformation. We found that even if a library administration greenlights data curation, they may not designate enough resources and may end up postponing such an initiative indefinitely.
Sorry, Karen, it looks like your slides might be fading in and out. I can see your cursor right now, but I can't see your slides.
Thanks. Let me stop sharing and reshare.
I can see him again.
How does that look? Okay, sorry about that. I think I had a notification pop up and it messed things up. All right. Okay, I'll keep going here. So as let's see, libraries. The thing I want to emphasize today here is that libraries do not need to wait for a perfect solution to begin addressing this problem. So there are some practical incremental steps that they can take today. The first one, start small. So save snapshots of high priority, high value data sets now, even if you don't have a place to store them in an official capacity. And use minimum viable solutions where possible. Cloud storage options like Amazon offer some stability at a pretty low cost. And for metadata, that's often a challenge because geospatial metadata formats can be very complicated and take a lot of training to fully fill out. But you can focus on interoperable discovery metadata using more lightweight formats like CSV or JSON documents. And then leverage collaborations, build partnerships, share expertise, and distribute the labor through regional or consortial collaborations if you have access to those. And then plan to grow, develop a phased strategy to expand infrastructure and capacity over time. So a leading example of this kind of proactive work is the Robinson Map Library at the University of Wisconsin-Madison. So staff there have been building a digital archive starting over a decade ago, motivated by the absence of a statewide geoportal and increasing demand from researchers. So in the early 2000s, they started by acquiring data sets informally to fulfill research requests. By 2012, they'd formalized the process, reaching out annually to data providers across the state. In 2014, they launched their own geoportal, which made the collection accessible. They did still have challenges with technical preservation, though. When the Robinson Map Library staff proposed moving their collection into the university's official preservation infrastructure, they were told the archive only accepted scanned maps, not geospatial data. So several years later, the university has changed its stance, but technical hurdles remain. A lot of this has come down to the fact that almost all of the data is packaged as zip files, which do not match long-term preservation policies. So specialized formats like geodatabases or shapefiles, they contain multiple component files with identical names that have different extensions. And this format is not well understood outside of GIS context. So this kind of complexity in geospatial data has made preservation a little bit more difficult. Despite these hurdles, the Robinson Map Library has built one of the most extensive state-level archives of geospatial data in the country. So their annual snapshots of road data now span more than 15 years. And when added to our BTAA-wide study, the one I did few slides ago about maps and geodata in the BTAA region, their contribution really stands out. Their road-related data sets substantially bridge the gap in geospatial coverage during the 2010s, especially, often exceeding the volume of publicly accessible data from all the other sources combined in the region. As future researchers seek examples of geodata from our time, the value of the Robinson Map Library collection will continue to rise, especially if Wisconsin remains the only state in the region with comprehensive historical geodata. So, inspired by Wisconsin's model, the BTAA Geospatial Information Network has launched a similar initiative. Our program, we've long harvested metadata for the BTAA GeoPortal, but we're now beginning to collect and curate actual data sets, especially those at risk of deletion or those that have already disappeared from public view. This graphic shows our strategic plan 23 to 27. In phase 1, we explored options and created a roadmap. We recently completed phase 2, what we call the groundwork phase, and we're about to enter phase 3, foundation. So rather than adopt an off-the-shelf digital preservation system like DSpace or Preservica, we decided to build on our existing infrastructure. We already had metadata curation and a discovery portal, as well as a custom built administrative interface for managing our records. So we've added a few other pieces. We established cloud infrastructure using Amazon and developed processing scripts to support curation workflows. Our custom administrative toolkit for backend metadata management now includes support for asset uploads, allowing us to integrate dark storage and description in, data storage and description in one interface. And we recently completed a pilot. This is a proof of concept that demonstrates that our workflows are feasible. We recently actually tested these workflows in a data rescue sprint. We targeted endangered federal data sets, including geospatial data layers from the National Center for Education Statistics. So in our upcoming foundation phase coming up this year, we'll start formal collaboration with selected data providers. This includes building relationships and agreements, refining our curation techniques, and establishing our first full curated collection. So for me, I feel like the technical barriers have been a little bit easier to address than some of these more social infrastructures. So really working to establish these partnerships and establish trust with data providers is something that we're working on next. But we're hopeful that our model, like Wisconsin's, will grow into a sustainable, scalable effort that ensures access to geospatial data, not just today, but for decades to come. So I'll leave you with this graphic. This is my last slide, created by some of my colleagues back in 2015. It's super simple, but I return to it again and again because it captures an essential concept. The value of data changes over time. So on the left, data about the present is valued very highly, but then data from last month or last year is often viewed as much less important. However, data from decades or centuries past tends to gain value once again. So the challenge for us is to anticipate this cycle and to capture today's data so that future generations will have access to it. And so thank you, everybody. I think we can have questions and discussion now.
Thanks, Karen. This was a really great presentation, and I think a super, super important topic that you're bringing awareness to. I want to start with two related questions, I think maybe for the non-library folks in the audience. So the first one is, for people outside of libraries, let's think about the data providers you just mentioned in phase 3, or academic centers, researchers, how can they contribute to the preservation of historical data sets, whether it be through individual efforts, organizational efforts, or partnerships with libraries? Do you have ideas on that? Sorry, Karen, you're muted.
All right, did I unshare my screen effectively?
Yeah.
Okay, so your question was about how individuals can help to contribute to this?
Yeah, individuals, whether they're, academic researchers or units, data
Mm,
providers, like you mentioned, for the next phase of the BTA
yeah,
GIN pilot. What are their
yeah,
roles in
yeah.
helping?
Well, one of the things that I would love to see more of is data researchers actually contacting librarians, and if there's something that you're not finding, request it, because what happens is a little bit of maybe a feedback loop where if people are using the data that's available, and if they're not seeing historical data, they may assume that it doesn't exist, and so then libraries may not be prioritizing that. So that's sort of just, I think, uh, proactively requesting it can be a really great help to give us more user stories and more reasons why doing longitudinal studies are important. There's also something called the Data Rescue Project that people may be able to volunteer for or get involved with, that involves, they have worked with groups like Reddit's Data Hoarders. I think that's a subreddit, people that are already saving local copies of data, even if they're not part of a professional or part of a library system or part of some kind of professional organization. As long as they're doing some kind of documentation about it, that kind of thing can be helpful. We are definitely starting to look back in time at the 90s and the 2000s to find data sets that have been stored offline somewhere, to see if we can bring at least records for them back online so that people can find them and know where they exist.
Thank you. I'm going to just remind folks in the audience, if you have questions, please feel free to put them in the Q&A, because I'm going to ask one right now that came in from the audience that kind of sticks with the data providers theme a little bit. So this is from Rachel. They say, I'm a geospatial analyst for the state of Colorado, and I feel like I don't have the skills in data governance to be able to properly archive the digital data of natural disasters or any emergencies to ensure that data is created properly and thus archived. Surely someone might want data sets from all the COVID-19 work that was done. What training exists for training current users and data providers to ensure that they have proper data governance skills for archiving historical data?
I think that's a really good question, and highlights one of the lessons learned from some of the data rescue efforts that went on back in like 2017, that it isn't enough to just download all the data that you can. You also need to document it. There's a concept that many of you are probably familiar with called FAIR. So findable, accessible, interoperable, and reusable, so that people, once data has been collected, can it actually be interpreted and reused? I feel like this is actually an area where we need more guidance, more public help on this. I'll mention the data rescue group again, sort of a multi-institutional group of volunteers, really, that are being helmed by librarians, some people from the Data Curation Network, some people from iAssist, to actually put in place some procedures to go through. But again, I feel like it's something that we do need more work on. There's another group called NISGIC, which is the National States Geospatial Information Council, that has started to take an interest in geospatial data preservation, and they're putting out a webinar series. I recommend taking a look at that to see what kind of things they've put out there. And maybe this is something that the Big Ten Geospatial Information Network can start looking into, creating some kind of better documentation for how people that are outside of the sort of metadata community can actually go through these steps.
Thank you. I'm going to grab the NISGIC link here and I'll share it in the chat in a minute
Oh,
for
thanks.
everyone. But for another audience question, this one from Jason, kind of building on this same topic, as we're thinking about data preservation, maybe by different entities and then use by different researchers or community members. Do you have any comment on the importance of provenance and ensuring authenticity. So for example, as we see federal documents created a few years ago, having portions altered or having to find someone with a prior PDF copy of that document, this asker has thought a little bit more about that.
Yeah, I do think that is an important issue. And it gets to a little bit to one of trust. One of the things I was talking about was establishing partnerships with data providers, partly because they don't really want to see something like that happen where the data gets changed or some kind of error is introduced, and then they feel like they might become liable for it. And so being able to save versions and sort of marking them as authoritative, like I think the Esri ArcGIS ecosystem now has a label that you can attach to certain data sets to say authoritative to indicate that that is kind of the original or the data set that the original provider stands behind. So I think documenting that is important. A lot of discovery interfaces don't always aren't super clear about adding a provenance section to the metadata, and I think that that's a good thing to add to provide really clear dates on when something was created and when it was accessed, things like that.
We have another question here from the audience, from Tanya. I noticed in the time series charts that mapping was strongly declining well before the digitized data began strongly ramping up. Are there any thoughts on what was driving that? I would have expected digitization to lead the trend, but it seemed to follow.
I think maybe more what we're seeing there is that mapping started to fall off in the 90s. And really stops being a major source in the early 2000s. And I think that maybe all of the digital data from that time is just no longer present anywhere. So maybe the way that the gap is displaying perhaps should, in reality, there probably were more data sets in the 90s that would be filling in what I think that strong drop off was.
Yeah, so that sort of illustrates the point that you're making, that
Okay.
gap wouldn't exist if those data were still preserved, and so we're seeing the
I
gap
think
kind of
so.
in action there.
I think so. Yeah. Yeah.
You talked a little bit about some examples, maybe at the national level, or a couple of universities that have been doing, you know, a decent job of archiving geospatial data in the past. Were there maybe some practices that you noticed that seemed to contribute to that success, or was there kind of a role of collaboration in those efforts? Anything that
Mm.
we can learn from in terms of what makes a successful archiving effort?
Well, I've noticed that at least like the Wisconsin example, a lot of that was actually driven by a more top-down approach. The legislation came through about 10 years ago saying that all parcels in the state had to be open by default. And they're not the only state in the nation that has declared that. Like I'm in Minnesota, we don't have that, but a lot of places, a lot of states do, and Wisconsin is one of them. I think what's different about what happened with them is that the state legislators and the Land Information Agency looked around and noticed that the university had already been saving all these data layers and already had at least a fledgling process for talking to data providers and collecting snapshots of data on an annual basis. And so from there, it was actually really easy for the legislators to say, oh, well, we're already doing that. Let's expand that to also collect road layers. I don't think they collect addresses, but they building footprints and a few other foundational data layers. And so I don't think that would have happened if Wisconsin hadn't already proactively started laying the groundwork for it. It just kind of eased the way for legislation. But at the same time, if that legislation hadn't happened through some magic of whoever was in power at that time, I don't know that they would have had enough leverage to get every single county to participate. So it's been kind of a two-way thing. And if you are in a state that a lot of counties won't or just don't want to participate in open data policies, then that's another consideration. Like you could go the route of what a place like the Adena Digimap has done, where you make agreements with them to collect their data and promise that it will only be for academic use. It's interesting. The Adena project told me that they get their stuff from the Ordnance Survey. You might have heard of the Ordnance Survey in the UK. That's the sort of main mapping agency, who has been very paranoid that their data is going to get out for free. But they've been doing this for 20, 30 years, and they've never had a problem with that. So it's possible that it might be easier if you start collecting restricted data in some ways, because then you have a policy in place and an agreement in place for exactly how it's going to be used. And then when your users go to access it, they might have to click a box saying that they won't freely share it.
Yeah, thank you. Thank you. I'm gonna ask a question here. I'll pose a kind of a two-part question to you, Karen, but I'll invite Harvey, Jordan, the folks from CURA into this conversation too. So the first part is just at a high level, what do you see as the major consequences of entering a current for now and for the future of entering this digital dark age of public geospatial data? And then secondarily to that, are there maybe examples of projects, research projects or initiatives that would not be possible if historical geographic information had not been preserved, whether that was in the past in maps or now, moving into other digital formats?
I guess in terms of what is happening, it's hard to completely say for sure that we're in a digital dark age, because there's so much data all around, and I don't really know who's saving it and what might be able to be pulled together. But what I suspect is that in years to come, it will be very laborious to resurrect data. A lot of it might decay, because as we know, digital formats decay much faster than paper formats. There's always changes in technology. So, the coverage files from the 1990s are going to be hard to turn into something that a modern GIS desktop software is going to be able to read. So I think it will be possible. It'll just be very laborious, and it might inhibit people wanting to do historical research if it takes a lot of effort to actually create it. In terms of some projects that have benefited from this, I mentioned a little earlier that I had gone to a webinar for preserving geospatial information put out by NISGIC, that's that National Council of States. And there was a great speaker named Denise Bleakley who has been worked in federal government data for many years. I think she's just recently retired. And she was talking about how she's so glad that they saved climate data from the 70s because it has really enabled them to be able to make the argument that the climate is changing, and that they have really solid data sets from every year going back 50 years to be able to prove that. And there's another project here in Minnesota called the Mapping Prejudice Project. Maybe many of you have heard about it, I'm sure, where they've taken old covenant language from housing deeds and mapped where they are throughout our county. They've done a few different counties in the state, and they can combine that with later data on redlining and using old maps and census data to figure out demographics and where city infrastructure has changed over time, to really tell the story of how real estate practices in restricting where people can live has really affected how the city was built. So something like that. What are the Sanborn maps that for today? A lot of people use Sanborn maps that came out over 100 years ago. What's the equivalent today is sort of the question I often think about.
Yeah, yeah. Well, I'm going to turn it over to Jordan here to end us on some logistical notes, but I'm going to end my part here, Karen, by quoting one of the audience members. So thank you. Very interesting talk. Bless our librarians. So I think, it's an important topic and folks are recognizing that. So thanks for everything here today.
Yeah, thank you. Thank you for inviting me.
Thanks, Josh. Yes, really appreciate everyone in the audience today. And just want to make you aware of our next speaker series. The next event that we have coming up in the public data for public good is the urgency of spatial data in 2025, building community-centered infrastructure for data discovery and recovery with Marnia Kolek. And that's again, July 18th. That's a Friday at 12 p.m. So we hope to see you all there. Thanks for your time today, and everyone have a great weekend.
Thank you.
Thanks, Karen.